The digital world that we now inhabit, image processing plays a pivotal role in shaping our visual experiences. A key technique in this domain is the process of dilation. This isn't just any routine operation, it's a transformative tool that has the power to amplify the quality of images and significantly enhance their interpretative value. Dilation is a process that manipulates the boundaries of regions of foreground pixels, typically white pixels, in a binary image. This operation enlarges these regions, growing their size, while simultaneously reducing the dimensions of any holes within them. The effect is a refined image with more pronounced features. And imagine a binary image, a canvas of black and white pixels. The process of dilation begins by identifying each background pixel, a structuring element, a simple shape used for the manipulation of the image, is superimposed on the image. The origin of this structuring element is aligned with the background pixel being considered. Now, if any pixel in the structuring element coincides with a foreground pixel in the image underneath, the background pixel is converted to a foreground pixel. However, if all corresponding pixels in the image are in the background, the pixel remains as such. This operation effectively turns any background pixels that have a neighboring foreground pixel into a foreground pixel, thereby augmenting the size of foreground regions and shrinking holes within these regions. It's important to note that dilation is the dual of erosion. In other words, dilating foreground pixels is equivalent to eroding background pixels. When using dilation, it's typical for the input image to be binary, with foreground pixels at pixel value 255 and background pixels at pixel value 0. Often, a grayscale image can be converted into a binary image using thresholding. When using dilation, it's also crucial to ensure that the polarity of the input image aligns with the dilation implementation being used. The size of the structuring element determines the intensity of the dilation effect. Larger structuring elements result in a more pronounced impact. However, similar effects can also be achieved by repeated dilations using smaller structuring elements. It's common to use a disc-shaped structuring element, especially with larger ones. Dilation has a plethora of applications. It can be used to fill in small spurious holes in images or for edge detection by dilating an image and then subtracting the original image. This highlights the new pixels at the edges of objects added by the dilation output. In conclusion, dilation in image processing is a powerful tool that amplifies the quality and interpretative value of images. By manipulating the boundaries of foreground pixels, it enlarges regions, reduces holes, and refines the overall image. As with any tool, its effective use lies in understanding its principles and applying them judiciously. So, whether it's to fill in small spurious holes or for edge detection, dilation is a tool that has the potential to transform the realm of image processing.